I forgot to record the signal. All right. So moving on. All right. So this is a nice little easy one. This is just asking you a straightforward question. What is the circumference of the circle? And it's a complete circle. So therefore we use the formula C equals what? 2 pi r. All right. And notice them tell you to use pi as what? 3.14. So it's going to be 2 times 3.14 multiplied by the radius. And what's the radius?
5.
It would have been 5, not true? It would be half of this value here. All right. And 2 5s, 2 5 is what? 10. All right. And because that's 1 0, the point moves one place to the right. You all see that? So it's just 31 point what? 4 centimeter. All right. And that's how you work it out without the calculator really, really fast. That's a nice little question. Notice I didn't say 2 times 3.14. I just said 2 times 5 give you 10 and just, you know, finish it off real fast. All right, any questions? No? Moving on. All right. All right. Let's look at this thing here. So we're looking so it's a metal bracket. All right. And the question says, what is its volume? All right. Now, what we need to understand is that volume is cross-sectional area times the length. So you notice that they give you the length of this thing here. So it's 2 inches long. So if you're to draw, what will happen, this is how it actually looks like, you know. It's like a metal thingy. Not sure what they use it for. But this is how it would look in as a 3-dimensional figure. All right. So that's how it looks. And this would have been the 2 inches. All right. So what we need to do still is to find the what? The area of this metal bracket and then multiply it by what? By 2. All right. Because the cross-sectional area would have been the area of that figure. All right. Now to find the area of this thing here, we're going to have to section it up. All right. Put it into parts. Cut it up into parts. So let's cut it like that. And let's cut it like that. So you notice we have 3 different what? Parts, or 3 different rectangles. So our job now is to find the area for each rectangle. All right. So as you can see, the top one is pretty simple. It's 3 by 1. And area for rectangle is length times width. So it's just 3 ones, what? 3. So the area for top piece is 3. But down here is also simple. 5 ones is what? 5. All right. The tricky part is in the middle part. All right. So we know that this part is 2 inches. Can somebody figure out this dimension here for the middle part?
13.
Hmm?
12.
Oh, sorry, not that part. That is 2, not true. It's not that part, sorry. It would have been this part here, so. Because this is already 2 inches. So what do they want? They want that little distance there. Let me just erase all of that. Well, I mean, what do we know? All right, we know that all of this. We know that all of this is how long?
5 inches.
It's 5, not true? All right, and we know say that this piece here, so we know that this little piece there is what? Is 3. All right, and that's 5. So what do you think the answer is?
So 2.
It will have to be 2 because it could be nothing else. Because if this piece, if this piece is 3 and this piece is 5, all right, you know, then this piece here must be 2, all right.
Yes, sir.
That's 3. That piece is 3, all right. Because if this are 3, you know, this would have to be 1 and this would have to be 1 to make it what? 5. All right. So you can look at it that way also. Three and 1 and 1 and 5. You know, I'm wondering if it's actually 2. I'm having second thoughts. I'm having second thoughts. Because look, all right, all of this is 3, right? All of this piece is 3. This is 1 and that's 1. You know, I'm wondering if so I'm saying I'm wondering if this is 1, 1 and 1. You see what I said? So I'm wondering if this piece is just 1. Because look, if this is 2, you know. All right, hold on. Let me show you something. all of this is 2, right? And then we have about this little piece here 2. But if you look at it, if you look at the proportion, that don't look like 2. It look like what? It look like 1. Not true?
Yes, sir.
And then the question didn't say it was not drawn to scale. So it means it's drawn to scale. All right. So I'm thinking that this little piece here is what? See, 1 and 1 and 1 give you 3. So it come like so boy, this not nothing to do with it. All right, everybody see the logic?
Proceed, sir.
Yeah, so this is 1. So we said that this piece here so is 3 1s is 3, 5 1s there is 5. All right, and 2 1s here so is 2. All right, so we have the areas for the 3 different what? Sections. All right. And then when you add up everything, you get 10. All right, 10 inches square. So this represents the cross-sectional area. And then to get the volume, we'll just multiply it by the 2. So the answer is just what? 20 cubic inches. You know, so, and you know, so it wouldn't have been, couldn't have been 2, you know, because if you put the 2 right there, so I work it out now, the answer for that is not there. So it you know. All right. Moving on. All right. Okay, so not sure what happened a while ago. It's like internet cut a while ago. All right, let me share up my screen. All right, look at this question here. Tell me what you think the answer is. Read very, very carefully. What do you think the answer is?
Sir, I think I did.
All right, let's check it out now. So it says the acceleration of a train can be calculated by dividing the difference between the final speed hold on. So the difference between the final and the initial speed, v minus u. All right. So we have v minus u. By dividing by the time. They kind of set it up in such a way that if you're not careful, you might miss out the part here. So the dividing part. So we're dividing by time. So yes, it's actually D. All right. All right, let's look at this one, 51. And this is a a distance time graph. All right, so what you need to understand about distance time graph, you see, is that, well, we know that speed is distance traveled divided by time taken. If you notice, if I divide the distance by this time, I should get what? Speed. All right. So if you look at this thing here, when the distance is 1, the time is 1. So if you divide 1 by 1, you get 1. Same thing for this one here. That's 2 divided by 2. 3 divided by 3. And 4 divided by 4. In other words, when you divide those two numbers, it gives you the speed. So the speed is, well, the speed is going up, not true? Because in the first instance, it was 1. It would have been 1 mile per minute. And the second one is what? 2 miles. 2 miles per what? Minute. Then 3 miles per minute. Then 4 miles per minute. All right. So what is happening to the speed of the car? It is what? It is increasing, not true?
Yes, sir.
It go up. So so you wouldn't say C, because C is saying that the car is traveling at a what? A constant. It means that the car upon one number and not move. Like you're upon, like in a highway, and you just there one like a something. All right. So A is it climbing a hill? Well, we don't know. We don't know if it, but not because the line is going up means there's a hill to go up. So if the line come down, it will drop down on a hill. No, not go so. All right. The car is accelerating. Yes. All right. The car is actually accelerating. What is acceleration?
Increase.
When you increase,
When something increases.
right? When it increases speed, not true?
Yes, sir.
Come on. And is the speed increasing? Yes.
Yes, sir.
So the car is what? Accelerating. All right. So that's the answer. It's like when you're at school and at lunchtime, you increase the speed, not true? To go to the line. All right. As opposed to when it's class time, you might find that the speed is constant. Or even stop. All right. Okay. Did we do this question?
No, sir.
All right. So I don't know. Look at it. It's a very big question. Hold on here. If you do food and nutrition or something like that,
Science.
Let me zoom in. Just look at it. Just look at it. What they're saying, you see? So this chart determines if you're overweight, if you're underweight, if you're normal or obese. All right. What they do is that it's not alone your weight alone they look at. They look at your height. If you look at it to the left, it is in its weight in pound. To the right, it's also weight, but in what? Kilogram. And if you look at the bottom here, you'll have height, and that will be feet and inches. And below the feet and inches would be the centimeter equivalent. All right. Now, on the chart itself, they have some numbers. All right. So let me show you something. So you have 18.5. Look at 18.5. All right. And then you have 25. So what they're saying is, if you fall anywhere between that little gray spot here, so you're considered what? Normal. Okay. And so anywhere in that range, you're normal. Means you know you have a normal body
mass.
to height, right? And I put a number there, and then you know, between 25 and 30, you know, you're overweight and etc. etc. All right. So let's look at the question now. So the question says, what is the BMI of an adult who is 5 foot, or that should be 5 feet, don't you? 5 feet and 3 inches tall, and somebody who is 170 pounds. All right. So 5'3" and 170. So 170 pound and 5 feet 3 inches. So let's look for 170 pound. So we're gonna go over here. So well, I think everything goes up by 10 pounds, not true?
Yes, sir.
Let me see. God, this is 140. So this is 150. So 170 will be right here, so don't you? That's 170, you know.
Yes, sir.
Let me see if we can go across. So 170. All right. Now the person height is what? 5 feet and 3 inches. So this is 5 feet 2. This is 5 feet 2. 5 feet 4. So 5 feet 3 most the right as well. By the way, 5 feet 3. Is that a short person? No. That's a medium height.
Yes, sir.
Yes, a medium height. I think 4 feet. Anything under 4 is considered short. So 5 feet 3. So 5 feet 3. So you bring it up. All right. Oh, that look like the person is overweight.
Yes, sir.
Let me do it again. 170 5 feet 3. Yeah, person is overweight. It's right on the upper part. So it covers right all of this that section here, which is about 30. All right. So if the person want to be normal, right? Like above normal, he or she would have to lose about I think 140 pounds. 140 pounds would give you a little above normal, not true? Right on the borderline. So the person weigh 170. So 40. So the person need to lose what? 30 pounds. Person need to lose what? A minimum of what? 30 pounds. All right. And that's what they do. That's what they do, and actually tell you, so boy, you need to work at this to be what? Normal. All right. All right. So this is a very useful chart, even for your own personal thing. And notice that the weight could have given to you in what? Kilograms, and or even what? Centimeter. But let me tell you, man, this thing is they have some everlasting diagrams. You wonder who on earth they get them diagrams from. Oh, hold on. This question is actually, it didn't ask us to say if the person is overweight or what, it asked us for the number. So well, that number would have been 30, not true? All right, so the BMI would have been 30, because I think it lands somewhere 3 right here, so right on that borderline here. So the answer would have been 30. All right, here's another speed time graph. See if you can figure this one out for me.
Sorry, I can go down a little bit because the option then, please.
Sir. Sir D. Sir, Mr. D. Sir, if you're talking, not hearing.
Oh my. Sorry about that. All right. Yeah. So as I was saying, you see, if you look at car B would have traveled 50 kilometers in 5 hours. So 50 divided by 5 would be 10 kilometers per hour. So that is the speed for car B. All right. Well, that's the answer, don't you?
Sir, but car A no slower than car B.
Huh?
Isn't car A slower than car B?
All right, let's figure it out. Let's figure it out. Car A is at what? 50, right?
Yes, sir.
And this is about what? 2.5.
Mhm.
What's 50 divided by 2.5?
20.
20 kilometers per hour. So it's the opposite, not true?
Yes, sir.
Car A is actually faster than car B. Remember saying the bigger the number, when the bigger the number means how fast you go, don't you? Agree?
Yes, sir.
Yeah. So car A is actually faster. It says, look at C. It says car B travels further than car A. Not true. Both of them travel what? The same distance. Right. And this part about B is incorrect. All right. All right. Any questions?
No, sir.
All right. So this thing about some look physics thing night, you know. Some look physics thing in this thing here. You have to just be careful. All right. Let me see. think we did some of these questions already.
So, sir,
Yes.
city and use question 10 to repeat back.
They don't repeat questions, you know. They don't repeat questions, but the questions are the same. Like they're very similar.
Oh,
They're very similar. All right.
yes.
There's this question I was doing the other day. Let me see. Oh, here's another BMI. All right, you know what? Like with upon this the speed time thing. Let's look at 42. What do you think the answer is?
Sir, car 1.
Car 1. All right, fair enough. If you look at car, all right, if you look at car 4. Car 4 is about 22. It's traveling about 22 and divided by 4. That's what, 11 over 2. That's 5.5 or 5.5 kilometers per hour. That's car 4. But look at car 1 now. Car 1 is about 60, not true? It's
Yes,
about
sir.
60 divided by
1.
about, I don't know, it's 1 point, probably 1.2 or something like that, but or 1.3. But I mean, you're gonna get a very big number, don't you? Because 60 divided by 1 is actually 60. So, well, let me just get it correct still. 60 divided by, say, 1.2. Is 50 kilometers per hour, which is the fastest. All right. So it's actually car 1. What you can also do, you know, is that any graph with the steepest slope would have been the fastest. All right.
Yes, sir.
So car 1 would have the steepest slope. All right. Here's another question. But wait, this question different, you know, because is it all that we have been looking at? These were distance what? And time. But no, this is no what? Speed and time. All right. So speed time graph is different from distance time graph.
Sir, D as in dog.
All right. Yeah, I would say that. Yeah, it's traveling at what? At a constant speed. Because if you look at it, look, if this means speed, you know, and let's say that speed here is, let's say 30. it's going at us one speed at a time and not moving. So the car is traveling at a what? A constant speed. The car is actually on cruise. All right. Increase in speed? No, you wouldn't see. Let me show you. Know which part one is an increase? Right here, so the car is what? Increasing its speed. And right here, so the car is what?
Decreasing.
Decreasing. It's a slow down. All right, so it's like you gas it up. And when you gas it up now, you reach a certain, you just start to cruise, and then you just slow down and then you stop. So the answer for 41 would have been definitely be D. All right, so here's a little tricky question. I don't know what you make of this. Any ideas or any wild guess?
Sir, 30.
Okay. All right. That's a good. That would be a good guess. If you don't know what you're doing, or you're reasoning it out.
So I'm gonna just say alpha 55 is like 27.5, and then we just look for the one the closest to that.
Yeah, it would make sense because I mean, this is a little bit more than half the tank. When the tank is full of 55, half of 55, as you said, is what? 27. All right, and a half. All right. So right at the middle there, so that will be what? 27 and a half liters of gas. And it look like a little bit above it, not true?
Yes, sir.
So that will give us what? 30. All right. All right. Did we do stuff? Did we do something like this? I don't know.
Yeah, we do that.
Okay. All right. Let us. Yes, I need to touch on something, Let's look at 27. We have to use a formula for this one, not true?
Yes, sir.
So it's PRT
Divided by 100.
Divided by 100. So that will go, so 40 and 16. What's 40 times 16?
640.
640. All right. Now look at 28 now. Now in CXC, right? They don't talk about simple depreciation. They talk about depreciation. All right. Now I am sure in your regular maths class, we did not teach simple depreciation. So this is very important. Now, if I had to take out the word simple, all right. First of all, depreciation means that it's been reduced. All right. So what we normally do is to find 20% of 160 grand. All right. By the way, what's 20% of 160,000? So that's 20 times 1,600. 32,000. Okay. So 20% of 160,000 is 32,000. That's a lot of money. All right. Now, in regular maths class, what we normally do? You see this money here, the 32,000? What we'll do is to subtract the 32,000 from the 160,000. And then when we do that now, we'll find 20% of the difference of those two numbers. And then that will give us the value when it was what? Depreciated. However, that is regular depreciation, but we're not doing that now. We're doing with simple depreciation, which is different. So let me tell you how simple depreciation works. All right. So what we do is also find 20% of the same 160 grand, which is what? 32,000. So at the end of year one, 32,000 will come off of the machine. And at the end of year two now, what they do is that they go back to the principal, the original principal, and that's the difference, and find 20% again of the 160,000. So if you do that for year two now, you will still end up with what? Another what? 32,000 for the end of year two. All right. Everybody follow?
Yes, sir.
Right. So with simple depreciation, you go back to the original. All right. So in 2 years time, in year one, 32 grand come off of the machine. Year two, and next 32 grand come off of the machine. So in total, a total of what? $64,000 will come off the what? The machine. All right. What is 64,000 from 160 grand?
$32,000.
You sure? It's 96,000.
Okay.
Follow? Right. So within the 2 years, you see, 64,000 come off of the machine. All right. So the value of the machine now will be 64,000 from the 100 and what? 60 grand. All right, let us look at this scale thing here. All right, so for this question, what you need to understand is, all right, well, two things you need to understand. To convert from centimeter to kilometer, you have to divide by 100,000. All right, so from centimeter to kilometer, you divide by 100,000. Oh, sorry. I may look on myself that have too much zero. All right, so let's look at this now. Now it says on a map, all right, with a scale of 1 to 75,000, the distance between the office and a conference room is 2 centimeters. What is the actual distance in kilometers? All right, so basically, what am I trying to say? You have a piece of map, right? And on the map, right, you have your office and you have the conference room. And what they're saying that on the map, one little piece of paper, 2 centimeters is between the office and the what? The conference room. So they want to know what is the actual distance. All right. Now, you may ask yourself, what does this mean, sir? Look at that. What does it mean? So that means, you see 1 centimeter that's on the paper. So if you're the map, if you're to measure 1 centimeter anywhere upon that piece of paper, that 1 centimeter represents 75,000 centimeter in real life. So 1 centimeter upon a paper represents what? 75,000 centimeter in what? In real life, in actual. All right. So if what they're saying that between the office and the conference room is 2 centimeters. So if it is 2 centimeters, all right, on paper, that means it's going to be 2 times what? 75,000 in real. All right, and what's 2 times 75,000?
$150,000.
150,000 centimeter. So in actual, 2 centimeters is 2 times 75, which is 150,000 centimeter. All right, but we don't want this in centimeter, what do we want it in kilometers? All right, and to convert from centimeter to kilometers, we have to divide by what? 100,000. So as you can see, these 4 zeros will cancel off, and we're dividing by 10, not true? So because we're dividing by 10, if you have 15 up here, so the point will move one place to the left, which is 1.5 kilometer. Any questions?
No, sir.
Look at this question here.
Sir, we do this already.
We that one already?
Yes,
All
sir.
right.
We do this too. We do that too.
Okay. Look at 47. 47, 48, 49. So those 3 questions, try them for me. 47, 48, 49. All right. Anybody work out 47? Well, 2 square is what? It's 4, aren't you? And then you have 2b, 2 times b, 2, 5 is what? 10. Subtract the square root of 16. Square root of 16 is what? 4. So I go.
Yes, sir.
So it's 4 times, hold on.
6.
What's the answer there? That's 4 6s and 24. Let me do this again. 2 square is 4. 2 times b is what? 10. Subtract the square root of 16, which is 4. That's strange. So I'm saying, I don't see the answer there. 10 subtract. It's not square root of 16. 4, 4, 4, 16. Unless I made a mistake somewhere. All right, but the answer is 24.
So you're supposed to switch in the exam. So you're supposed to switch in the exam. Hopefully. Just make a random guess.
I want because this 2 square thing here does look away. Does look off, awkward. I'm wondering if that is a square. This 2 square.
Oh.
Yeah. I'm wondering if this should be a square. If it was a square, that would have been 4 square. That would not give us what? 16. And then 16 times 6. That was 96. So I'm not speculating, because the answer is not there. So I'm thinking this is a square. So you'll get 16 subtract 6, which is 96. If you're in the exam and you, well, I don't know, just write a note, no answer, but I think it's actually a square.
Okay, sir.
Yeah. Because the answer for 2 squares aren't even there. All right, 48. Well, these are 2 like terms. So 4y plus 3y is what? 7y equals what? 28. And then just divide everything by 7. Y is equal to what? 4. All right, so this one here now, 49. Well, what you do is that to find x, you get rid of the 1 to the left by adding 1 to the left. and also 1 to the right. So that will go away. So that's 2x equals 2. Divide both sides by 2. X equal 1.
Sorry, first, me ask you.
I first I do them something.
No, first me do it, but I first me see that the method they are working.
So what you normally do? Bring it over?
No, me didn't even know that, sir. But I first me see something like this. Me always just try like everything.
Well, I mean, you could have said if you put 1 right there, so you could have said 2 1s 2, 1 from 2 give 1. You could have tried that.
Okay.
But to work it out mathematically, that's what you'd have to do.
Okay, sir.
All right. That means look at this question here. 54. I'll be here in some and put this in. What do you think the answer for that is? 54.
Sir, 90 degrees.
So I couldn't 90. What you need to know is bearings. Bearings measured clockwise from north. So this is 0, 90, 180, 270. In between, you see, is 45. So 90 plus 45 is 135. All right, 180 plus 45 is 225. So in between each is 45, 45, because 245 we are 90. So it says a boat traveling in a southwesterly direction. So southwesterly direction would have been between south and west. So I'm just thinking, boy, that would have been a best answer. That is actually southwest, the 225. All right. So that was a first for me. I never seen a bearing question before. All right. Oh, here's 2 more. Look at these 2 questions. See if we can work out those 2.
Sir, B. Sir, we're not hearing you.
Oh, sorry. Yeah, so what I'm saying, you could have just guessed y to be 11 because 2 times 11 is 22. 22 plus 5 is 27. Or do it algebraically. If you want y, you don't need a 5 on the left hand side. How you get rid of a 5? By subtracting 5 on the left. But if you subtract 5 on the left, you have to subtract 5 on the what? On the right. So 2y is equal to 22. You divide everything by 2. So y is equal to 11. So this is the mathematical way of doing it. When you have a plus, you subtract to get rid of it. When you have a minus, you add. So for example, 49 now, we have 6x minus 2 equal 40. So because I don't want a minus 2, I'm going to have to what? I'm going to add the minus, add a 2 to the left. If I add it to the left, I have to add it to the right to make the equation balance. So minus 2 plus 2 will give us 0. So this is equal to what? 6x equal what? 42. And then you divide everything by 6. And what's 6 into 42? Is it 7?
Yes, sir.
This one kind of hard to guess, you know. Let us work it out. All right. Look at 47. So all you need to do is what? Replace f with what? 95.
95.
So you have 95 subtract 32 times 5 over 9. What's 32 from 95?
63.
63?
Yes.
Times 5 over 9. What's 33 divided by 9?
35.
You sure? 3
Yes,
into
7.
7?
Yeah. 7 times 5, 35.
Right, and 75 is 35. All right, so I'm gonna end class at 2 here. It's 1:38. Let's look at 44. Well, I mean, what you're going to do is add up all those numbers and divide it by what? By 7.
Maybe 16.
When you add up these numbers, what do you get?
100 and stuff. That's 69.
16.
Yep.
All right. You all know what range means, right? Range
Difference between the highest and the lowest.
difference between the highest and the lowest, right? And 45 is talking about the range. Look at 46. Well, all probability must add up to 1, not true? So if I say 0.5, the probability of me going town today is 0.5. What's the probability of me not going in town today?
0.5.
0.5. Because when you add both of them, you should get 1. So therefore, the answer for this would be what?
D.
0.49.
So I'm gonna understand this.
All right, what is 0.51 plus 0.49?
I got your one too.
Yeah, that'll give you 1.
Oh,
It's just that they just, they use 0.51.
oh. I understand. I think them that like you like say out or something. I think that come out or something.
Oh no. Did we ever do this table here?
No sir. You can try.
All right. But look at it and tell me what you think is 9W.
Sir, 8 minutes.
Right, it will be 8 minutes
Yeah,
because
we didn't do this already.
yeah. So 9W5104 is right here. So it's supposed to left that time, but it left that time, which is 8 minutes difference.
Yes, sir. So I will do that already.
Yeah, we did those flow charts. All right. Look at 15. So what you work is out to do? Pretty much common sense.
So we get the so yeah, the time is 1.29 times 2 because of 2 pence by,
All right.
and then add it to the $4.50,
Mm-hmm.
and then the total would be $7.08. Yeah, subtract it from the $8 would have left 92 cents.
Oh, so it will be D then.
Yes, sir.
Would you able to do this without a calculator?
Yeah, yes, sir.
All right. All right. So that's the whole point. These questions, you know. For example, look at 40. I mean, I'm not gonna lie to you. I mean, you may know what to do, but when you get it, you can't do it. How would you set out this question? 14.
Sir, that one you're not clicking on.
So what's the difference? What's the difference in cost between 0.5 kilogram of red grapes at? So basically this is a unit price for the grape, but I just 0.5 kilogram alone you want. So it's just 0.5. Hold on. So 0.5 times 4.5. Because that's a unit price. Difference now between
0.5 times 3.
right, 0.5
Oh.
times 3. All right. So work out that now.
So 0.75.
0.75.
Yes, sir.
Tell me something. What is do something? What is 0.5? You see? Multiply by 1.5.
0.75.
0.75, aren't you? Let me show you something. I don't know, in algebra, you have A. All right, look. Let us say I have A times B, and I have A times C in algebra, right? So if you notice, this is 0.5 and this is also 0.5, aren't you?
Yes, sir.
So in algebra, you see what you can do? Because A and A common, you pull out A. And what left back is just B subtract C. So A would be 0.5, you know. And then B subtract C would be just 4.5 subtract 3, which is 1.5. So that's why I asked what is 0.5 times 1.5. So rather than multiply these two, then subtract them without a calculator. You could just do this. Follow?
Yes, sir.
But it only works when you have like two 0.5. All right, let me see if we can find one question like this that is similar. If this one I will give it, you know, get the one from that one. I'm not getting through the question. Okay, I'm not I'm not seeing a question like that. Look at 15. By the way, 14 is the same set out, you know. If you want to set out 14, it is still 2.5 times what? 1.9. But no, this is saying find the total. So you add 1.5 times 2.92. But you have to work this one out right through.
Cause nothing.
Yeah, there's nothing common here. And that's rough, you know, because I mean to sit down and work this out without a calculator. Work out that with a calculator. And after you work it out, you have to add it. That's rough. So you have to just prepare for that. All right, look at 15. This is basic wage. All right, for this question, so an employee earns $85.36 per hour for the first 40 hours and time and a half this hourly rate for any additional work hours over 40. How much will an employee earn for 52 hours? All right, so for 40 hours, right? This is our rate. So you have to say 40 multiplied by 85.36. And that will give us the regular wage, the regular basic wage. All right. Then no, the person work 52 hours. So out of the 52 hours, the 40 hours, you'd have she basically earn what? 12 hours extra, not true? So to work out that now, it's gonna be 1.5, all right, times the $85.36 multiplied by the amount of overtime hours. All right, and that's what you have to do to work out all of this, and this is a woolly power. All right, so compute that for me, and that will give you the total earnings. All right, so let me just take out my calculator.
Sorry, go be 4,950.88.
See, okay, all right. Let me see. Question 18, but you know, look at 18. Any ideas? It is not straightforward here. All right, if you were to have a discussion, right, with somebody, how would you actually work this out?
So you would have to change it to an input fraction.
Well, yes, you'd have to, yeah, you'd have to change it, right? But what just tell me, what would you work? What would you add? Or what would you do?
Add what I distance to and from.
Add these two numbers here, these two fractions.
Yes, sir.
Where you walk on? It says each morning, right? All right, so you have home, you have nursery, and you have work. All right. It says each morning a worker drops her son at the nursery. All right. So she go from home to nursery. That's 5 3/4. All right. And then no, hold on. Each morning a worker drops her son to the nursery. And then she go to work, Drew, from the nursery to her work. Which is what? 2 3/4, 2 3/5. All right.
Yes.
But guess what now? If you read this, it says each morning a worker drops her son at the nursery. Check this out, on her way to work and picks him up in the afternoon on her way home. That means what I mean, you have to consider the fact that boy a two distance. So you have to go back all the way back at home to, not true? So
Yes.
you work, yeah, it's just like every day, you know. You leave. Some of you even do this. You have a little sister or little brother goes up by the school, primary school or the basic school. So you leave home, you drop off your little brother at the school, then you go to high school, and then what? You go pick him up and then what? Carry him back home, not true? So that's the element that's missing. So what you do, you add these two numbers, add these two fractions, and then times it by 2. And that will give you a complete journey. All right. So I think that's the tricky part about this question here. Is that the fact you have to consider, say boy, you have to what? Times it by 2. So it's not only from home to nursery to office. It's from the office back to the nursery and then back home. And everything is actually in this first statement here. So and this is definition of she driving to work each day. So what is the total number of kilometers that she drives each work day? All right. And so basically this is actually describing her, what she does on a daily basis. As it relates to the answer, you have to say what, 5 4 is what, 20, so that's what, 23 or 4. All right. 2, 5, that's what, 13 over 5. LCM is 20. 420 goes 5. 5 times 23 is what? 3 5 is 15. 2 5 is what? 10. And 1, 11. 520 goes 4. 4 times 13. 4 3 is what? 12. That's what? 52. So that's what? 160 what? 7 over 2. That's how you go. And then the times is now by 2. Because this represents the journey to and to work, to nursery to work, and then to work. So what you could do is 2 to 2 goes 1, 2 into 20 goes what? 10. All right, so we end up with 167 over 10. All right. That looks like 16 and 7 over 10. That's how you go. Yeah, man. You can get 16 groups of 10 out of that. So that's the answer. Answer is D. But guess what, you know? If you're to add the two fractions, the answer is actually there for A. All right, it's actually 7 and 9 over 20. But the answer is actually what? D. All right. All right, so did we do this?
No, sir.
All right.
Oh my.
This is a flow chart. Which of the following values of x will make the expression equal to 0? Input x and add x, subtract 12, 0.
So I scroll up a little bit more, maybe we can see, so we can see options, please.
You know what this is saying? Let's try 0. You input 0. You square, when you square 0, what you get? 0 square? 0 square is 0, don't you?
Yes,
And
sir.
then you add the same x, which is 0. So 0 plus 0 is 0. And then 0 subtract 12 is negative 12. So what this is saying, you know, is if you reach right here, so you get 0, you end the program. But when we use 0, we get negative 12. So it can't be 0. Let's try 3. You input 3, and then 3 square is what? 9.
9.
And then you add x again, which is actually 3. So 9 plus 3 is 12. Right? And then you subtract 12 from 12, you get what? 0. So that's the answer.
Oh,
Is it?
yes, sir.
Because when you answer, so if it's not 0, it goes along this path here and go back up and try again until you get 0. So in other words, it will only work if you get 0. And this is basically write programs. This could be a password, to open an email, and this is what the flowchart looks. You put in the wrong character, it keeps on saying no, no, no. You understand?
Yeah, try again.
Right.
So IT use for me, sir.
Yeah, man. Look at 29. It says which are the following as the lowest value. How would you do this without a calculator? All right, so one suggestion is to put everything as a percentage. Because right now you have fraction, we have percentage, we have decimal. So if you put everything as a percentage, we can probably compare them better. So to find the percentage of anything, we just times it by 100. So for example, this one, if I times by 100, because it have 2 zeros, the point will go 2 places to the right. So this is just 29%. All right, so we have 31%, we have 29%. This now, 205, how you convert that as a percentage, just times it by what? 100.
20.
So 5 into that was what? 20. So that's actually 40%. And then 1/3 now, if you times it by 100, you get 33.33. So the biggest one is what? 40%, which is what? 2/5.
No, sir. They have to be limits.
Oh, sorry, the lowest. So the lowest would have been
0.29.
0.29, right? Because that gives you 29%. All right. Call today,
All right, sir.
We'll call today, all right? So I don't know. The exam is when? Thursday?
Yes, sir.
All right. So I don't know. I might just do a couple a couple questions, before. All right. So that's it. All the best. All right.
Yes, sir.
All right.
Later.
All right.
Thanks.
Thanks, sir.
All right. Cool. No problem.